This is a very happy day. We have 27 problems about exponents and radical expressions, and I will guide you through all of these questions. If you want to try to solve these questions yourself, you can download this paper as a PDF in the link below the video. I will use these 11 rules to solve each of the questions. If you are unfamiliar with these rules, you can look at my video here explaining each of them and why they actually work. Now it's time to start. Question number 1. And the first questions are the simplest one. X raised by 2 times x raised by 3. And we see that these two powers have the same base, the same number in the bottom, and then we're looking for a rule here that have the same letters at the bottom. Rule number 1 is working here, and it tells me that we can add the exponents to each other. So this equals x raised by 2 plus 3, and of course it will be x raised by 5. And this is the answer. Question 2. Simplify the quotient x raised by 5 divided by x raised by 2. And when we have a quotient like this and the same base here, then it's rule number 2 that we will use. And it tells me that we can subtract the exponents with each other. So this equals, if we use rule number 2, it equals like x raised by 5 minus 2, and then it will become x raised by 3. And this is the answer. Number 3, simplify x raised by 4 and then raised by 2 again. And this is rule number 3, and it tells me that you can multiply the exponents to each other. So the only thing that we have to do is take x raised by 4 times 2, and then it equals x raised by 8. And this is the answer. Number 4, simplify x raised by minus 2 divided by x raised by 3. And then it's rule number 2 again, because we have the same base and the same base here. So we can use rule number 2, and then it will become like this. X raised by minus 2 and then minus 3. And we can write this like x raised by minus 5. And you can choose to write the answer like this, or you can use rule number 4 if you want to, and put the whole power into the denominator instead. If you change the sign in the exponent from minus to plus. So you can write it like 1 divided by x raised by 5. So you write it down here and change the exponent from minus 5 and to 5. So either one of these answers will work. It's a matter of your choice. Question number 5. Okay, this is a harder question, and you can do it very fast if you know what you are doing. We have the square root of x raised by 6, and when it's the square root, it is an invisible number 2 here. Okay, so I write this down because it's easier for me to explain it for you if the number is there. So you can write it in an instant like this. X raised by 6 divided by 2. And I will tell you what's going on. Look at the expression here in rule number 9. Okay, we have the base here. So the base, we can take the yellow color as the base here. Oh, blue color. So this is our x in our expression. And with the rule number 9, you can write it like this at the left. And then we have the base here in a power. And this is the x here that I have written for you. So next we have a raised by m here, and then the exponent get to be the numerator in the exponent here. So here we have m, And in our example, we have the number 6, and it's the number 6 up here. And then we have the nth root will become the denominator in the exponent. And we have the invisible number 2 here, and then it must mean that the exponent in our cases are x divided by 2. So this is rule number 9. Now it equals, of course, x raised by 3. And this is the answer. You can do it in another way too, or a different other ways. You can reason like this. The square root of something, of x raised by 6 in our case, is that the number or that expression that times itself equal this thing inside here. And we know that x raised by 3 times x raised by 3 must be x raised by 6 by rule number 1, because 3 plus 3 equals 6. So you can figure it out this way too. Or you can write the number 6 here like 3 times 2, and then use rule number 3 to write it like a power raised by the number 2. So if you use rule number 3, then you can write like this: the square root of x raised by 3 and then raised by 2. And then we know that the square root here are the inverse operation to raising a number with the exponent 2. So we can cancel these out, the square root and the exponent 2. We cancel them out, and then it will become x raised by 3 again. So you can do it like this. Or you can do it like this: the square root of x raised by 6 equals the square root of x raised by 3 times x raised by 3. And then if you use rule number 10 from right to left, like here, then you can write it like square root of x raised by 3 times square root of x raised by 3. And if we have two square roots times each other, then they cancel each other out. So the result is the thing inside one of them. So x raised by 3. It's always worked like this. If you take the square root of 9, it equals 3, times the square root of 9 equals 3, then it must mean 3 raised by 3, and the result equals the thing inside one of these square roots. Okay. So, final answer, x raised by 3. Okay, question number 6. This is almost identical to question number 5. You can use rule number 9 and in an instant write it like this. You take the base x, you raise it to the exponent here, 9, but divided with this root, with 3 in this case, so it equals x raised by 3. Okay, so it was like going from here and then to here. And of course, like question number 5, you can do it in some other ways too. Number 7, simplify the square root of 4x raised by 2 times y raised by 4. And the exponents here are only working with the base that are just behind it, or beside it. So the number 4 here is not raised by 2, because the exponents and the base are so close, but the invisible multiplication sign between the 4 and the x is not so hard, so the exponent here works on only this number x. So you can use rule number 10 to split these 3 factors inside the square root. So it equals square root of only 4 times square root of x raised by 2, and then times square root of y raised by 4. And square root of 4 equals 2, because 2 times 2 equals 4. Square root of x raised by 2, then we can cancel the square root and the exponent with each other, it equals x. And square root of y raised by 4 equals y raised by 2. Because y raised by 2 times itself equals y raised by 4. You can do it like this if you want to. Y raised by 4, the square root of this equals y raised by 2. And raised by 2, the square root of this, and then cancel this exponent with each other and getting this bit. Y raised by 2 if you want to. But the final answer is 2xy squared. Question 8. Compare 2 raised by 10 versus 4 raised by 5. Which is greater, or are they equal in size? Both of these powers have different bases and different exponents to each other. And the thing we want to do is get the same base or the same exponent in both of these powers. And then we can compare the sizes. So I take one of these and try to make the base the same or the exponent the same. I will start with 4 raised by 5, and I will try to rewrite this base here to the base number 2. And I know that 4 equals 2 raised by 2. It also equals 2 times 2, but it's better, I think, to write it like a power. So this number 4, you write it like a power, and then raised by number 5. And then we can use rule number 3. And of course, it means that you can multiply the exponents to each other. So it will become 2 raised by 2 times 5, and it equals 2 raised by 10. And then we see that 4 raised by 5 equals 2 raised by 10. So this expression here are equal to each other. And you can, of course, start with 2 raised by 10, like this. Rewrite the 10 as 2 times 5, and rewrite it like this, and then the power of the base 4. So you can go from left to right or right to left. Number 9. Compare 2 raised by 15 versus 3 raised by 10. The bases, we can't so easily, I think, get this expression to have the same base, because it's hard to get a 2 to become a number 3. Okay, but the exponents can we get to the same exponent, like this. I see the exponent 15 here, and I know that it equals 3 times 5. Okay, 10 equals 2 times 5, and number 5 is in both of these exponents. And then we can rewrite this power here, 2 raised by 15, like this. We can write it like 2 raised by 3 times 5, and the other power here we can rewrite with 3 raised by 2 times 5. And then if we use rule number 3, we can write it like this. The first one, 2 raised by 3 and then raised by 5, and I'm using rule number 3 from right to left, from a multiplication in the exponents to a power raised by another exponent here. And then the same thing here, I can rewrite it like 3 raised by 2 and then raised by 5. And now we have the same exponent in both these powers, the exponent 5. So the base, what is the base? 2 raised by 3 equals 8, and 3 raised by 2 equals 9. So the first one is 8 raised by 5, and the last one is 9 raised by 5. So which of them are greater? The greater one is this one here. So the greater one is 3 raised by 10, because it has the greater base. Question 10, write in exponential form. And this is an easy question. You can use rule number 9 if you want to, but rule number 7 is an easier one. So rule number 7, from right to left, tells me that I take the number of the root, and this is the square root, is an divisible number 2 here, and rewrite it like this. I take the base, this is our a in the formula, and then raise it to 1 divided by this number here in the root. So 2 raised by 1/2. And this is the answer, 2 raised by 1/2, or if you want to, you can, of course, write it like this, 2 raised by 0.5. Number 11, write in exponential form. And that means that you will rewrite this expression with something, a base, raised by an exponent. Okay, so the first thing that I will do is to rewrite the denominator in an exponential form. And I can do it with rule number 7 here. If you take rule number 7 from right to left, then the number a here is our number 5. And the number a will become the base in the power. So I write a 5 here, and then you should write it like raised by 1 over the number in the root. So 1 over 3 in our example. So like this. And then we have used rule number 7. And we are not done yet. We have to move this power here from the denominator, and you can do it with rule number 4. Yes, because rule number 4, if you're going from right to left, it means that you can move a whole power up from the denominator if you change the sign in the exponent. So we can move this and write it like this, 5 raised by, and then we put a minus sign in the exponent, so minus 1 over 3. And this is the answer. Then we have written it in the exponential form, like 5 raised by this whole bit here. And it's exactly like this. Number 12, simplify the fourth root of x raised by 8. And we have done things like this before. This is rule number 9, from right to left, from here to here. And we can do it at once. We take the base, we raised by the exponent here, divided by the number for the root. So 8 divided by 4. Okay, and then it will be x raised by 2. And this is the answer. If you want to do it in a longer way, you can write it like this. X raised by 8 and then raised by 1 over 4. Then you're using rule number 7 from right to left. And then you can use rule number 3 to multiply the exponents with each other. So it equals x raised by 8 times 1 over 4. And it equals x raised by 8 over 4 equals x raised by 2. So you can do it in a short way or in a longer way if you want to. Number 13, simplify. And we have a multiplication with 2 powers inside here, the parentheses, and then raised by 6. And you can start from outside and in, or from inside and out. And I will start from inside and out. So my first mission here is to multiply these powers with each other. And these powers have the same base. And then rule number 1 is working very well. So I can add the exponents to each other. So this is equal to x raised by 1 over 2 plus 1 over 3. And then raised by 6. But when you have 2 fractions here and add them together, you must have the same denominator. So I have to multiply this thing with 3 up and down, and this thing with 2 up and down. So it equals x raised by 3 divided by 6 plus 2 divided by 6 and then raised by 6. So x raised by 5/6 and then raised by 6. Okay. And now we can use rule number 3 to multiply the exponents with each other, and then it will be x raised by 5 divided by 6 and times 6, and the 6's are cancelling each other out, and it equals x raised by 5. And this, my friend, is the answer. If you want to, you can start with taking this number 6 here and get it inside the parentheses, and you can do it with rule number 5 from right to left. If you have a multiplication inside a base, the exponent can be rewritten for the both factors inside the parentheses. So the number 6 here, you can move it like this and like this. So it equals x raised by 1 over 2 raised by 6 if I write all the thing, and times x raised by 1 over 3 raised by 6. But of course, you can use rule number 3 and multiply the exponents right away with each other. And then it will be x raised by 1/2 multiplied with 6. It equals 3. Times x raised by 1 over 3 times 6. It equals 6 divided by 3. It equals 2. And then use rule number 1 to multiply these powers with each other. Then we're adding the exponents to each other. So x raised by 3 plus 2 equals x raised by 5. So it's working from inside and out, or from outside and in. Number 14, a multiplication in the numerator. So we start with this. We have the same base. We use rule number 1 here. So we have x raised by 2 over 3 plus 1 over 4 if we add the exponents to each other. And then divided by x raised by 3/4, like this. To calculate the addition here, the sum, then we are multiplying with 4 and 4 and 3 and 3 to get the same denominator. And then we can write it like this. X raised by 8/12 plus 3/12 equals 11 divided by 12. Okay? And then divided by x raised by 3/4, like this. And now we can use rule number 2, because we have a quotient here, and then we can subtract the exponents to each other. So x raised by 11 over 12 minus 3 over 4. And we have to multiply to get the same denominator. So multiply this one with 3 and 3. And then it equals x raised by 11 over 12 minus 9 over 12. And then it will be x raised by 2/12. And when you divide the numerator and the denominator with 2, it equals x raised by 1/6. And this is the answer. And of course, you can also write it with rule number 7 as a root if you want to. So it equals the 6th root of x if you use rule number 7. So it's simplified even like this. Number 15, you have one square root inside another square root, and I don't think square roots are so funny to work with. So I use at once rule number 7 to get rid of the square roots. And rule number 7, you can rewrite a square root like a power raised by 1 over 2. So it equals the whole bit here raised by 1 over 2, and inside the parentheses we have x raised by 3 and then times x raised by 1 over 2, or 1/2. Inside the parentheses, if we work from inside here, you can use rule number 1. You can work from outside too, if you want to. And rule number 1 tells me that I can add the exponents to each other. So x raised by 3 plus 1/2. And the whole bit raised by 1/2. And when we're working the sum here, we need to get the same denominator on both times. So I get writing an invisible number 1 here, and then multiply it with 2 and 2 up even in the numerator. So the denominator here is 2 and 2. So inside the parentheses we have x raised by 3 over 2 plus 1 over 2. No, 6 over 2. Plus 1 over 2 and then raised by 1 over 2. So x raised by 7/2 raised by 1/2, and you can use rule number 3 to multiply the exponents to each other. And then we have x raised by 7/2 times 1/2, and it will be 7/4. Like this, x raised by 7/4. And this is the answer to the question. And of course, you can rewrite it by rule number 9 if you want to write it like the 4th root of x raised by 7. But I don't think that this is any easier. But you can do it if you want. Number 16, the square root of something times the cube root of something. And I will start with rule number 10, and it works with square roots and all other roots too. And it means that you can split the factors inside it. So I can rewrite the whole thing like the square root of 4 times square root of x squared times cube root of 8 and times cube root of x cubed. And then a lot of things cancel out. Square root of 4 equals 2, because 2 times 2 equals 4. Then the square root and the exponent 2 cancelling each other out, so we have only x here. The cube root of 8 equals 2, because 2 times 2 times 2 equals 8. And then the cube root of x raised by 3, then the cube root and the exponent cancel each other out, and then it will be only x. So 2 times x times 2 times x, 2 times 2 equals 4, and x times x equals x squared. Yes, box. Number 17, write without radicals, exponential form only. And we have done these sort of questions before. We can use rule number 9 and at once rewrite this as x raised by 5 over 3. If you go from here to here. And I have showed you why before. What is half of 4 raised by 12? And it's not 2 raised by 12, and it's not 4 raised by 6. I will write it like this from the start. I take the whole thing and divide by 2. And then I will rewrite the number 4 as the base 2. So 2 raised by 2 equals 4. And then raised by 12 and divide by 2. So the number 4 here, I rewrite it like 2 raised by 2. And now I use rule number 3 to multiply the exponents to each other. So it will become 2 raised by 24 and then divide by 2. But the number 2 in the bottom equals 2 raised by 1, and then you can use rule number 2 and subtract the exponents from each other. So it equals like this: 2 raised by 24 minus 1 equals 2 raised by 23. So this is the final answer. Question 19. What is 3 times 9 raised by 4? So I will start with rewriting the number 9 with a power with a base 3. So I know that 9 equals 3 raised by 2. So the whole expression will be like this. So the 9 here, I replace it with 3 raised by 2. And then I use rule number 3 and multiply the exponents to each other. So 3 times 3 raised by, and 2 times 4 equals 8, like this. And now I have the same basis here on the 2 powers, because the number 3 will become a power if I write the exponents 1 here. And then I can use rule number 1 to add the exponents to each other. And it will be 3 raised by 9. Not so hard and funny. Number 20, simplify. Oh, we have a lot of different bases. Let's rewrite them like this. 8 equals 2 raised by 3, I think. 4 equals 2 raised by 2. And 2 equals just 2. Then we have the same base, 2, 2, and 2. Okay, so I take all of these numbers and rewrite the bases. 2 raised by 3 raised by x times 2 raised by 2 raised by x plus 1, and then divide by 2 raised by 5x. Okay, so this is always a hell of a start. Can you say so in English? Okay, I don't know. We use rule number 3 and multiply the exponents to each other. And then we have 2 raised by 3x times 2 raised by 2 times the exponent, and we write it in a parenthesis like this. And then divide by 2 raised by 5x. You multiply this number 2 inside the parenthesis like this and rewrite the whole thing. You use rule number 1 in the numerator to add the exponents to each other, and then the whole thing will be like this: 2 raised by 3x plus 2x plus 2 divided by 2 raised by 5x. And in the numerator we have 2 raised by 5x plus 2, and then divide by 2 raised by 5x. And then we can use rule number 2 to the whole quotient here, and to subtract the exponents. So it will become 2 raised by 5x plus 2 minus 5x. So 5x and minus 5x cancel each other out, and then 2 raised by 2 equals just the number 4. So this whole thing equals numbers 4. Number 21. Oh, another expression with different bases. So we have the base 3, we have the base 9, and the base 27. And all these bases can be rewritten with the base 3, because 9 equals 3 raised by 2, and 27 equals 3 raised by 3. So I rewrite the whole thing as this: 3 raised by 2x plus 3 times 3 raised by 2, and then raised by x, divided by 3 raised by 3, and then raised by x plus 1. So all these bases, this thing here, we have rewritten them like this. we use rule number 3 to multiply the exponents to each other, this one and this, and this and this. And 3 times this one, I can at once take 3 times x and 3 times 1. So it will be like this. 3 raised by 2x plus 3 times 3 raised by 2x divided by 3 raised by 3x plus 3. Okay. And now, like the question number 20, I can first, if I want to, use rule number 1 to add these exponents to each other, and then use rule number 2 to subtract with the exponent here. But I can do it in the same way too, in the same operation. So I can write it like this. I take 3, I add these two, and then subtract with this if I combine these two rules. So 2x plus 3 plus 2x, and minus a parenthesis with the 3x plus 3. Okay. So what do we get from here? 3 raised by, if I take away this parenthesis sign here, this sign inside the parenthesis will change to minus. So shup, 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 and then minus inside, because we have a minus sign before the parenthesis. So 2x plus 2x minus 3x equals only x. And then we have 3 and then minus 3, and they cancel each other out. So it only means 3 raised by x. Okay, this is the answer. Number 22. Oh, we have another one with different bases here and different exponents. So what do we do with this thing? We can't rewrite 48 as a power. I don't think it's possible. Okay, what can we do with it? We can rewrite it like this. It's 2 times 24. 24 equals 2 times 12. 12 is 2 times 6, and then 6 is 2 times 3. So the prime factors are 2 times 2 times 2 times 2 and times 3. It equals 2 raised by 1, 2, 3, 4, and then times 3. Okay. Number 12, we do like this. We have 2 times 6 and then 2 times 3. The prime factors are this thing here. So it equals 2 raised by 2 and then times 3. So I rewrite the bases as prime factors instead. Look what's happened. So 48. 2 raised by 4 times 3, and then the whole thing raised by 2. Number 12, 2 raised by 2 times 3, and the whole thing raised by 3. And now we can use rule number 5 from right to left and move the exponent into each factor inside the parenthesis. So this number 2 here, we move it first here and then here. And the number 3, we move it here and here. So we use rule number 5, but when we have 2 raised by 4 and raising again with 2, we know that we can multiply the exponents with each other if we use rule number 3 in this one. So we combine these rules. So 2 raised by 4 raised by 2, we write it like 2 raised by 8. 4 times 2 equals 8. So this. And then times 3 raised by 2 divided by the same thing. 2 raised by 2 times 3 equals 6. And then 3 raised by 3. And now we can use for these powers here with base 2 we can use rule number 2 and subtract exponents. So the whole thing here equals 2 raised by 8 minus 6, and then times 3 raised by, and we subtract the exponents even here. So 2 minus 3, so minus 1. It equals 2 raised by 2, of course, and times 3 raised by minus 1. But I like to move this power here to the denominator instead with rule number 4, because I don't like negative exponents so much. So I can do it like moving the whole power to the denominator if I change the sign in the exponent from minus to plus. So it will be equal to 2 raised by 2 divided by 3 raised by 1. And then 2 raised by 2 equals 4, and then we can divide it by 3. So this is the answer. And you can do it in a shorter way, I think. The faster way to do this is to use rule number 2 again, but only for the number 2's. So it equals 2 raised by 8 minus 6, and it will be number 2 here. So this thing here equals this. But for the base 3, I will write it like this. I will write 3 times 3. You can think of it like this. And then at the denominator, you have 3 times 3 times 3. So I can cancel this and this and this and this at once. And then, of course, it will be 4 divided by 3. So we don't have to rewrite it first with rule number 2 and take them minus each other, and then rewrite it with rule number 4. You can think that if you have 3 3's in the denominator and 2 in the numerator, it must mean that it's 1 more in the denominator. So this will be left if you cancel all of these others out. This is, I think, a smart way to think about this problem. Okay, number 23. We have 3 raised by 2 and raised by x plus 1 times a parenthesis with 2 raised by x and times 9 raised by minus x. And because of the multiplication sign here and here, we don't need this parenthesis sign here. We can cancel this out. Okay, so the things that we are gonna do is to use rule number 3 and multiply these exponents to each other. And 2 times x equals 2x, and 2 times 1 equals 2. So we have 3 raised by 2x plus 2. And I was using rule number 3 here. And then times 2 raised by x, and the base 9, we can write this as a base 3. We will have the same base if we can. So the number 9, I write it like this: 3 raised by 2 and then raised by minus x. So this base equals this. And then we can use rule number 3 again here to multiply these exponents to each other. And then we get like this: 3 raised by 2x plus 2 times 2 raised by x and times 3 raised by minus 2x. Okay, so the powers that have the base 3, then we can add the exponents because of rule number 1. So the green powers is equal to 3 raised by 2x plus 2 minus 2x. And then the 2x and minus 2x in the exponent cancel each other out. And then times 2 raised by x. And then we have it, I think. 3 raised by 2 equals 9. And then we have times 2 raised by x. And this must be the answer. Number 24. Compare 6 raised by 6 versus 8 raised by 4. And we can't just take the base 6 and change it to base 8, not in an easy way. So the things that we can do is to factorize the bases. Okay, so number 6, we can say that it equals 2 times 3, of course, like this. And number 8 equals 2 times 4, but 4 equals 2 times 2, so 8 equals 2 raised by 3. Yeah. Okay, so the base 6 we can change to base 2 times 3, and then raised by 6. And then we can use rule number 5 from right to left to get the exponent to move into the base, into the parentheses. So we have 2 raised by 6 times 3 raised by 6. Okay, we pause there and take the other power. 8 raised by 4 equals, and we change 8 to 2 raised by 3, and then raised to 4. And then we use rule number 5 again and say that it equals, 2 raised by 12. But how compare this one to this? Okay, here we have 6 2's. 2 times 2 times 2, 6 times. And here we have 12 2's. So I can rewrite this bit here because it equals 6 2's, 2 raised by 6, and times 2 raised by 6, if I use rule number 1 from right to left and split it into 2 powers. And then I am absolutely sure about the first factor here. 2 raised by 6 equals 2 raised by 6. They are equal to each other, of course. So they are equal. And then I can compare the other factor. Which is largest? 3 raised by 6 or 2 raised by 6? And then I know that this one is the greater one. So that must mean that 6 raised by 6 is greater than 8 raised by 4. Number 25, simplify, and we have a nice expression here. Okay, so the things that I will do first is to move this parenthesis inside, to move this exponent inside the parenthesis. And I can do it with rule number 6. Okay, so then it will be, if I write the whole thing out, it will be like this. We have 2 raised by 2 and then raised by 2, and 3 raised by 3 and then raised by 2. But I can use at once rule number 3 and multiply these exponents to each other. So this will be 2 raised by 4 and this will be 3 raised by 6. So I write this instead here. Okay, so 2 raised by 4 divided by 3 raised by 6. The next factor, I change always the cube root to a power and to the exponent 1 over 3. So I write it like this. 3 raised by 6 divided by 2 raised by 3 and raised by 1 over 3, 1/3. Because the cube root, we can change it with rule number 7 from right to left. And then we can do the same thing as we did here. We can move this exponent into the parentheses and multiply with the exponent that already is in the parentheses. So we will have as follows: 2 raised by 4 divided by 3 raised by 6 times 3 raised by 6 times 1/3. And 6 times 1/3 equals 6/3. And it equals 2, I think. This is what we get. And in the base, 2 raised by, and 3 times 1/3, it equals 1. So this is only a number 1, and we don't have to write it. When you multiply two fractions, you can multiply the numerator, so we get like this, and you multiply the denominators, and we get like this. And then we use rule number, bum, 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 bum. We can use rule number 2. And write this a little easier. So, with 2 raised by 4 and 2 raised by 1, then we subtract the exponents, and then we have 2 raised by 3. But when we do this with the base 3 here, then we get negative exponents, and I don't like it so very much, but I can show you how it's done. We have 3 raised by 2 minus 6, it equals minus 4. So you can write it like this, but I prefer to move this power here with the negative exponent into the denominator instead, and change the sign in the exponent. And this I can do with rule number 4. And then I take this power and put it down here. So I get 2 raised by 3 divided by 3 raised by 4 instead. So change the floor from up and down if you change the sign in the exponent. This is the rule. So you can answer like this, or you can, of course, evaluate it. 2 raised by 3 equals 8. 3 raised by 4 equals 81. So you can answer like this too, of course. And you can go from here and write it like this if you want. 2 times 2 times 2 times 2 and times 3 times 3 divided by 3 times 3 times 3 times 3 times 3 times 3 times 2, and then cancel the factors out. Shup, yup, and yup, 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 yup. And then we have only 2 raised by 3 divided by 3 raised by 4. So you can go to solve this problem in a very many ways. Number 26. Which is greater? 12 raised by 5 or 8 raised by 6? And as we did in number 24, we factorize the bases here. So number 12 equals, of course, 2 times 6. 6 equals 2 times 3. So 12 equals 2 raised by 2 and times 3. Okay, number 8, we already know that it equals 2 raised by 3. So I change the basis to this. We have 12 raised by 5 equals 2 raised by 2 times 3 raised by 5. And then I can use rule number 3 to move the, no, not rule number 3, rule number 5 from right to left to move the exponent into the parentheses. So it will be like this. 2 raised by 2 raised by 5, but we know we can multiply the exponents, so it means 2 raised by 10 here, and times 3 raised by 5. Okay, next one. 8 raised by 6 equals, the 8 was 2 raised by 3, and then raised by 6. And then we move the exponents in with rule number 3 and get 2 raised by 18. And because we have here, have 2 raised by 10, so we split this one into 2 raised by 10 and times 2 raised by 8, so that we have the first factor equal in both these expressions. So this is equal to each other. So we have to compare 3 raised by 5 with 2 raised by 8. So which is greater? And I think we have to do the calculation here. Okay, 3 times 3 equals 9. So 3 times 3 equals 9. If I have 2 3's more, 9 times 9 equals 81. And if we take 81 times 3 again, we get 243. Okay. And 2 raised by 8. Okay. 2, 4, 8, 16, 32, 64, and 128, and 256. So 256. And we see that 2 raised by 8 is the greater one. And then we know that the greater one here is boom, 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 2 raised by 8. So this one, and that must mean that the greater one is the power 8 raised by 6. And the last question is question number 27, simplify. And this isn't any hard question at all. We can use rule number 3, and when we have a power raised to something, we can multiply the exponents. And this works inside here. This bit inside equals, this equals 2 raised by a times b. And if we have 2 raised by a times b and then raised by c, then we multiply with c as well. So the first factor equals 2 raised by abc. So we use these rules 2 times. And the next factor, then we use this rule again, and we multiply the exponent a minus b with the exponent c. So we get 2 raised by, a parenthesis, a minus b times c. And then the only thing that we have to do is to move c into the parenthesis here and multiply. So this will be 2 raised by abc times 2 raised by ac minus bc. And then we can use rule number 1 and add the exponents. So final answer must be 2 raised by abc plus ac minus bc. So you can write it like this, or you can move this term in the exponent. You can use rule number 2 to move it down in the denominator. If you use this rule, it must mean that you have like this: 2 raised by abc plus ac and divide it by 2 raised by bc. Because if you use rule number 2 from right to left, then the negative term, it changes to the exponent here in the denominator. So this is rule number 2 from right to left. Okay, so you can choose one of these. And then we have solved all these questions. If you like this video, please give me a thumbs up. My name is Jonas, a Swedish math teacher. And yeah, see you in the next one. Bye bye.